Look up at the night sky, a peaceful, silent space, with stars twinkling like diamonds pinned on a black velvet cloth. But that peace holds a secret. Our Earth, this fragile blue island, is moving at hundreds of thousands of kilometers per hour through a place that is not empty at all. In reality, we are living in a cosmic shooting gallery. Around us, there are millions of rocks and balls of ice, remnants from the dawn of the solar system, drifting on orbits that cross our own path. They are called near-Earth objects, or NEOs, by scientists. Most of them will never come near us. They are just silent neighbors in the dark. But a few of them have their own stories, their own names. There are names like Bennu, an ancient messenger containing the secrets of life. And there are names like Apophis, the god of chaos, who once made the entire world hold its breath. Welcome back to Science for Sleep. If this journey to explore these lonely travelers sparks your curiosity, a gentle tap of the like and subscribe buttons will help us continue these voyages together. And as always, I would love to know where in the world you are listening from. Please feel free to leave a greeting in the comments. Tonight, we will not look to the sky with fear. Instead, we will tell the stories of these travelers. Where do they come from? What have they seen? And what are we, the small observers on a blue planet, doing to understand and protect ourselves? This is a story of potential dangers, but it is also a story of discovery, of intellect, and of the peace we find when facing the majesty of the cosmos. Let us begin together. Our story of these lonely travelers begins with our first subject, an asteroid designated 101,955 Bennu. From our telescopes, Bennu is just a faint, moving point of light. But through the eyes of our robotic spacecraft, it has revealed itself to be a world of profound scientific interest. It is a rubble pile asteroid, not a solid, monolithic rock, but a loose collection of boulders, gravel, and dust held together by its own weak gravity. Its shape is that of a spinning top, and its surface is incredibly dark, blacker than charcoal, a sign that it is rich in carbon. And it is this carbon that makes Bennu so special. But where did this dark spinning top come from? To understand its origin, we must travel back in time and journey outward, past the orbit of Mars, to a vast, donut-shaped region of space known as the asteroid belt. This is the great, failed construction site of our solar system. Over 4.5 billion years ago, when the planets were forming, the immense gravitational influence of the gas giant Jupiter, our system's great bully, constantly stirred up the material in this region. It prevented the millions of rocks and planetesimals here from ever coalescing into a single, large planet. The asteroid belt is a collection of leftovers, the primordial building blocks of a world that never was. Bennu is not a native of this belt. It is believed to have been born from a much larger, parent asteroid in this region, a great carbonaceous body, hundreds of kilometers in diameter. Sometime in the last billion years, a powerful collision shattered this parent body, and Bennu, a small fragment from that ancient cataclysm, was thrown onto a new, chaotic orbit. This new path brought it out of the main belt and into the inner solar system, where its orbit now crosses that of the Earth. It is a lonely traveler, a dark and ancient piece of a lost world, now wandering the cosmic neighborhood as one of the most well-known near-Earth objects. It is a relic, a time capsule that carries within it the chemical secrets of the early solar system, a time before planets, before life. And it is for this reason that humanity decided it was a world that we must visit. Bennu was not just a potential threat, it was a scientific treasure chest, a pristine time capsule carrying the original ingredients of our solar system. And so, humanity decided to reach out across millions of kilometers of space to touch it. This led to one of the most ambitious and delicate missions ever undertaken by NASA, the OSIRIS-REx spacecraft. The name itself is a story, standing for origins, spectral interpretation, resource identification, and security, regolith explorer. Launched in 2016, the spacecraft began a long, patient journey, traveling for over 2 years to rendezvous with the small, dark asteroid. Upon its arrival, OSIRIS-REx did not immediately land. It entered into orbit around Bennu, becoming, for a time, a tiny moon orbiting a tiny world. For months, it meticulously mapped the asteroid's surface, using its suite of advanced cameras and scientific instruments. The images it sent back were stunning. They revealed a world far more rugged and chaotic than expected. Bennu's surface was a jumble of massive boulders, sharp rocks, and loose gravel, with very few of the smooth, sandy areas that the mission team had hoped to find for a safe landing. The challenge was immense. The mission plan called for a maneuver known as touch and go, or tag. The spacecraft would have to descend slowly, make contact with the surface for just a few seconds, release a puff of nitrogen gas to stir up surface material, and then collect the resulting sample in a special container before pushing off again. After months of careful analysis, the team identified a small, relatively clear spot within a crater, a site they named Nightingale. The target area was only a few meters wide, like trying to land a helicopter in a small parking space surrounded by giant rocks. The tension during the sample collection event was palpable. On the 20th of October, 2020, with a signal delay of over 18 minutes each way, the spacecraft began its slow, autonomous descent. The world watched as OSIRIS-REx, guided only by its onboard computers, navigated the boulder-strewn landscape. It extended its robotic arm and made perfect contact with the surface. The nitrogen gas fired, and a cloud of dark, ancient regolith was blasted into the collection head. The spacecraft had touched the past. In fact, the sample collection was so successful that the collector head was overflowing with material, and the team had to stow the precious sample ahead of schedule to prevent it from leaking away into space. With its cargo secure, OSIRIS-REx began its long journey home. And in September 2023, it flew past Earth and released its sample return capsule, which blazed through our atmosphere and landed safely in the Utah desert. Humanity had successfully retrieved a piece of a distant, ancient world. The potential threat of Bennu had been transformed, through human ingenuity and curiosity, into an unprecedented scientific opportunity, a chance to study the very building blocks of life in our laboratories here on Earth. The successful return of the OSIRIS-REx sample capsule was a moment of triumph, a testament to years of planning and precision engineering. But the real story began when scientists in a carefully controlled cleanroom in Houston first opened the container. Inside, they found a treasure trove of dark, crumbly material, a small handful of an ancient world delivered to our own. This was not just rock and dust. This was a time capsule, holding secrets from the very dawn of our solar system. The initial analyses of the Bennu samples were more stunning than scientists had dared to hope. The material was incredibly rich in carbon, a key building block of life as we know it. But the most profound discovery was the presence of water. It was not liquid water, but water molecules that had been chemically locked inside the structure of clay minerals billions of years ago. Imagine a tiny, microscopic sponge made of clay, absorbing water in the ancient past, and then holding onto it, preserving it through a long and violent journey across the solar system. The presence of this hydrated clay is powerful evidence that Bennu's parent body was once a much larger, water-rich world. But even more exciting was the discovery of complex organic molecules within the samples. These are the carbon-based molecules that form the very foundation of biology, including amino acids, which are the building blocks of proteins. These findings lend powerful support to a long-held hypothesis about the origin of life on our own planet. The theory suggests that early Earth, while having some of the necessary ingredients, may have received a crucial delivery from space. Asteroids like Bennu, rich in both water and organic compounds, could have acted as cosmic couriers, seeding the young, barren Earth with the very molecules needed to kickstart biology. The water in our oceans, the carbon in our bodies, the very stuff of life, may have first arrived here as a passenger on a dark, rubble pile asteroid, a lonely traveler from the outer solar system. The story of Bennu, therefore, becomes our own origin story. In studying this dark, distant rock, We are looking at a sample of our own cosmic heritage, a glimpse into the chaotic and creative processes that allowed our world to become a living one. While the story of Bennu evolved from a potential hazard into a triumphant scientific discovery, our next traveler introduced itself to the world with a much more alarming tone. We journey now to the year 2004, to a time when our planetary defense systems were still in their relative infancy. Astronomers at the Kitt Peak National Observatory in Arizona were conducting a routine sky survey when they spotted a new, faint object moving rapidly across the heavens. It was designated 99,942 Apophis, named after the ancient Egyptian god of chaos and destruction, a name it would soon seem determined to live up to. As astronomers around the world began to track this new asteroid and calculate its orbit, a deeply unsettling picture emerged. The initial calculations were not precise, carrying a degree of uncertainty, but they suggested something that had never been seen before with such a significant object. There was a non-trivial probability that Apophis, an asteroid over 300 meters in diameter, large enough to obliterate a major city, could strike the Earth. The date of the potential impact was Friday, the 13th of April, 2029. The initial odds were placed at around 1 in 2,700, a number far too high for comfort in the world of planetary defense. For the first time, an asteroid was elevated to a level 4 on the Torino scale, the 10-point system used to categorize impact hazards. Level 4 signifies a meritorious encounter deserving of attention by astronomers. A dry, scientific phrase that thinly veiled a genuine and serious concern. It meant there was a greater than 1% chance of a devastating regional impact. For a brief, tense period in late 2004, Apophis became the most dangerous object ever discovered in space. It was a wake-up call for the scientific community and the world. A tangible reminder that the cosmic shooting gallery was real, and that an impact was not just a question of if, but of when. The story of Apophis was no longer a gentle scientific curiosity. It was a race against time to refine its orbit, to reduce the uncertainty, and to determine if humanity was facing its first predictable, large-scale cosmic threat. The initial, alarming calculations for Apophis sent a shockwave through the small, dedicated community of astronomers who track near-Earth objects. The threat, while statistically small, was now real and named. And so began a quiet, intense, and global scientific effort. This was not a story of panic, but of patient, meticulous work. This is the story of the planetary sentinels. All over the world, astronomers at both large observatories and small, dedicated facilities turned their telescopes toward the faint point of light that was Apophis. Every clear night, they would capture new images, precisely measuring its position against the background of distant stars. Each new data point, each new observation, however small, was crucial. These observations were sent to the Minor Planet Center, the global clearinghouse for all asteroid and comet data. Here, the new positions were added to the growing file on Apophis, and with each addition, scientists could refine its orbit, slowly chipping away at the uncertainty. The key was to extend the observation arc, the length of time over which the asteroid's path had been tracked. The longer the arc, the more accurately its future path could be predicted. This work required incredible precision and collaboration. It involved powerful radar observations, particularly from the Arecibo Observatory in Puerto Rico and the Goldstone Deep Space Communications Complex in California. By bouncing powerful radar signals off the asteroid's surface, astronomers could measure its distance and velocity with astonishing accuracy, far greater than what was possible with optical telescopes alone. This radar data was the game changer. It allowed scientists to dramatically reduce the cone of uncertainty that surrounded Apophis's future trajectory. Over the next few years, as more and more data poured in, the picture became clearer. The probability of an impact in 2029 was steadily revised downwards, from 1 in 2,700 to 1 in 5,000, and so on, until it was finally ruled out completely. A global sigh of relief was breathed. But the story was not quite over. The calculations revealed that while the 2029 flyby would be a miss, it would be an incredibly close one. So close, in fact, that Apophis would pass through a small region of space known as a gravitational keyhole. If it passed through this keyhole, Earth's gravity would alter its orbit in just the right way to set it up for a potential impact on a subsequent pass in the year 2036. The threat, though deferred, remained, and so the patient work of the Skywatchers continued. The patient work of the Skywatchers continued for years, each new observation of Apophis refining our understanding of its path. The threat of a 2036 impact, dependent on the asteroid passing through a tiny gravitational keyhole in 2029, remained a small but persistent possibility. But in 2021, astronomers were able to use powerful radar observations during another distant flyby of Apophis to completely rewrite its future. The new data was so precise that it allowed them to map the asteroid's trajectory for the next century with incredible accuracy, and the result was definitive. Apophis would not pass through the gravitational keyhole in 2029. There was no risk of an impact in 2036, or indeed for at least the next 100 years. The god of chaos had been tamed by mathematics. The threat had been neutralized by observation, and in its place, a new and exciting opportunity emerged. With the danger gone, the close approach of Apophis on Friday, the 13th of April, 2029, has transformed from a source of anxiety into one of the most anticipated celestial events of our lifetime. On that day, Apophis will pass by the Earth at a distance of just 32,000 kilometers. This is a remarkably close shave in cosmic terms. It is closer to the Earth than our own geostationary satellites, the ones that provide our weather forecasts and satellite television. For a few hours, Apophis will be visible to the naked eye, appearing as a star-like point of light moving steadily across the night sky. A silent visitor from the deep solar system, visible to millions of people across Europe, Africa, and Western Asia, it will be a once-in-a-thousand-year opportunity for science. Space agencies around the world are already planning to study Apophis as it passes by, potentially even sending missions to rendezvous with it. Scientists will be able to map its surface in incredible detail, study its composition, and perhaps even observe how the Earth's gravity affects its spin and structure during the close encounter. The great encounter of 2029 is no longer a story of fear, but a story of discovery. It is a testament to the power of science to turn a potential catastrophe into a spectacular and safe astronomical event, a chance for humanity to look up in unison and witness the quiet, predictable, and beautiful dance of the cosmos. The story of Apophis demonstrates our remarkable ability to predict and neutralize a specific threat through patient observation and calculation. But it also reminds us that our solar system has always been a dynamic and sometimes violent place. To see the true, unfiltered history of this cosmic shooting gallery, we need only to look up at the night sky, at our closest and most familiar companion, the moon. Its serene, pockmarked face, a canvas of light and shadow, is a beautiful and silent testament to a long and brutal history of impacts. The great, dark patches we see, the so-called seas or maria, are vast, ancient basins carved out by colossal impacts billions of years ago, later filled in by dark volcanic lava. And scattered across its entire surface are countless smaller craters, each one a scar from a past collision. It begs the question, if the moon has endured such a relentless bombardment, why has the Earth, its much larger and more gravitationally powerful neighbor, seemingly been spared? Our world, from a distance, looks so smooth and serene. The answer is that the Earth has not been spared at all. It has just been better at healing its wounds. Our planet is protected by two powerful, constantly working defense mechanisms. The first is our atmosphere. This thin blanket of air, so vital for life, also acts as a powerful, fiery shield. When small to medium-sized asteroids enter our atmosphere at hypersonic speeds, the friction is so intense that they are heated to thousands of degrees and vaporize into nothing more than a fleeting streak of light. A beautiful meteor, or shooting star. The vast majority of potential impactors never reach the ground. They are completely incinerated, tens of kilometers above our heads. The second reason is that the Earth is a living, breathing planet. Its surface is constantly being recycled. Unlike the Moon, which is geologically dead, the Earth has weather, erosion, and plate tectonics. Wind, rain, and ice work as patient sculptors, slowly grinding down the edges of ancient craters over millions of years, filling them with sediment until all visible traces are gone. And on a grander scale, the very continents themselves are in constant, slow motion. Old seafloors pulled back into the mantle, and new crust is formed at mid-ocean ridges, a planetary scale resurfacing process that erases ancient scars as if they were never there. Life itself helps to cover the wounds, as forests grow and soil forms over the sites of old impacts. The Moon has none of these healing mechanisms. It has no significant atmosphere to burn up intruders, and almost no geological activity to erase the evidence. It is a dead world, and therefore, a perfect historian. Every crater it has ever received is preserved in near pristine condition, a permanent and visible record of the solar system's violent past. So when we look at the tranquil, cratered face of the Moon, we are not looking at a different history. We are looking at our history, a story that has been erased from our own planet's surface. The Moon is our silent witness, its scarred face a quiet reminder of the countless cosmic battles our world has survived. And among those many impacts, one, in particular, would change the course of life on Earth forever. The Moon's serene, pockmarked face tells a story of constant bombardment, a history of impacts that our own world shares, even if its scars have been healed by time. But 66 million years ago, one of these lonely travelers, far larger and more consequential than most, had its orbital path intersect, not with the Moon, but with the Earth itself. This was the day the world was changed forever. It was an asteroid or comet, roughly 10 kilometers in diameter, the size of a mountain, moving at a speed 20 times faster than a rifle bullet. It blazed through the Earth's atmosphere in a matter of seconds, a brilliant, terrifying star in the daytime sky. Its destination was a shallow sea in what is now the Yucatan Peninsula in Mexico. The impact released an amount of energy equivalent to billions of atomic bombs. The initial flash of heat and light vaporized everything for hundreds of kilometers in every direction, instantly boiling the sea and blasting a colossal crater, over 150 kilometers wide and 20 kilometers deep, into the Earth's crust. The impact sent a seismic shockwave, equivalent to a magnitude 11 earthquake, rippling through the entire planet, triggering volcanoes and earthquakes on the other side of the world. It created mega tsunamis, some hundreds of meters high, that raced across the oceans, devastating coastlines thousands of kilometers away. And it threw trillions of tons of vaporized rock and debris high above the atmosphere. As this superheated material rained back down across the globe, it ignited global wildfires, incinerating the great forests of the late Cretaceous period. But the immediate devastation, as terrible as it was only the beginning. The fine dust and soot from the impact and the subsequent global fires created a thick, dark shroud that enveloped the planet, blocking out the sun's light. The world was plunged into a prolonged period of darkness and cold, an impact winter that may have lasted for years. In the dim twilight, photosynthesis ceased. The plants died. The herbivores that ate them starved, and the great carnivores at the top of the food chain, with nothing left to hunt, followed suit. The great dinosaurs, the magnificent rulers of the Mesozoic era, who had dominated the planet for over 150 million years, could not survive this new, dark, and barren world. Their long reign was brought to an abrupt and final end. In the oceans, the collapse was just as severe, wiping out the great marine reptiles and the iconic ammonites. It was an event of almost unimaginable destruction, But in every great ending in Earth's history, there is a new beginning. The fall of the dinosaurs left a massive ecological vacuum. And cowering in the shadows, in burrows deep underground, were our own distant ancestors, small, shrew-like mammals who had managed to survive the cataclysm. With the great reptiles gone, the world was now open to them. The Chicxulub impact did not just end the age of dinosaurs, it triggered the dawn of the age of mammals, the age that would eventually lead to us. The lonely traveler that brought death from the sky also, inadvertently, cleared the path for our own existence, a profound and humbling reminder of the chaotic and unpredictable nature of life's long story. The story of Apophis demonstrates our remarkable ability to predict and neutralize a specific threat through patient observation and calculation. But it also reminds us that our solar system has always been a dynamic and sometimes violent place. To see the true, unfiltered history of this cosmic shooting gallery, we need only to look up at the night sky, at our closest and most familiar companion, the moon. Its serene, pockmarked face, a canvas of light and shadow, is a beautiful and silent testament to a long and brutal history of impacts. The great, dark patches we see, the so-called seas or maria, are vast, ancient basins carved out by colossal impacts billions of years ago, later filled in by dark volcanic lava. And scattered across its entire surface are countless smaller craters, each one a scar from a past collision. It begs the question, if the moon has endured such a relentless bombardment, why has the Earth, its much larger and more gravitationally powerful neighbor, seemingly been spared? Our world, from a distance, looks so smooth and serene. The answer is that the Earth has not been spared at all. It has just been better at healing its wounds. Our planet is protected by two powerful, constantly working defense mechanisms. The first is our atmosphere. This thin blanket of air, so vital for life, also acts as a powerful, fiery shield. When small to medium-sized asteroids enter our atmosphere at hypersonic speeds, the friction is so intense that they are heated to thousands of degrees and vaporize into nothing more than a fleeting streak of light. A beautiful meteor, or shooting star. The vast majority of potential impactors never reach the ground. They are completely incinerated, tens of kilometers above our heads. The second reason is that the Earth is a living, breathing planet. Its surface is constantly being recycled. Unlike the moon, which is geologically dead, the Earth has weather, erosion, and plate tectonics. Wind, rain, and ice work as patient sculptors, slowly grinding down the edges of ancient craters over millions of years, filling them with sediment until all visible traces are gone. And on a grander scale, the very continents themselves are in constant, slow motion. Old seafloors pulled back into the mantle, and new crust is formed at mid-ocean ridges, a planetary scale resurfacing process that erases ancient scars as if they were never there. Life itself helps to cover the wounds, as forests grow and soil forms over the sites of old impacts. The moon has none of these healing mechanisms. It has no significant atmosphere to burn up intruders, and almost no geological activity to erase the evidence. It is a dead world, and therefore, a perfect historian. Every crater it has ever received is preserved in near pristine condition, a permanent and visible record of the solar system's violent past. So when we look at the tranquil, cratered face of the moon, we are not looking at a different history. We are looking at our history, a story that has been erased from our own planet's surface. The moon is our silent witness, its scarred face a quiet reminder of the countless cosmic battles our world has survived. And among those many impacts, one, in particular, would change the course of life on Earth forever. The moon's serene, pockmarked face tells a story of constant bombardment, a history of impacts that our own world shares, even if its scars have been healed by time. But 66 million years ago, one of these lonely travelers, far larger and more consequential than most, had its orbital path intersect not with the moon, but with the Earth itself. This was the day the world was changed forever. It was an asteroid, or comet, roughly 10 kilometers in diameter, the size of a mountain, moving at a speed 20 times faster than a rifle bullet. It blazed through the Earth's atmosphere in a matter of seconds, a brilliant, terrifying star in the daytime sky. Its destination was a shallow sea in what is now the Yucatan Peninsula in Mexico. The impact released an amount of energy equivalent to billions of atomic bombs. The initial flash of heat and light vaporized everything for hundreds of kilometers in every direction, instantly boiling the sea and blasting a colossal crater, over 150 kilometers wide and 20 kilometers deep, into the Earth's crust. The impact sent a seismic shockwave, equivalent to a magnitude 11 earthquake, rippling through the entire planet, triggering volcanoes and earthquakes on the other side of the world. It created mega tsunamis, some hundreds of meters high, that raced across the oceans, devastating coastlines thousands of kilometers away. And it threw trillions of tons of vaporized rock and debris high above the atmosphere. As this superheated material rained back down across the globe, it ignited global wildfires, incinerating the great forests of the late Cretaceous period. But the immediate devastation, as terrible as it was only the beginning. The fine dust and soot from the impact and the subsequent global fires created a thick, dark shroud that enveloped the planet, blocking out the sun's light. The world was plunged into a prolonged period of darkness and cold, an impact winter that may have lasted for years. In the dim twilight, photosynthesis ceased, the plants died, the herbivores that ate them starved, and the great carnivores at the top of the food chain, with nothing left to hunt, followed suit. The great dinosaurs, the magnificent rulers of the Mesozoic era, who had dominated the planet for over 150 million years, could not survive this new, dark, and barren world. Their long reign was brought to an abrupt and final end. In the oceans, the collapse was just as severe, wiping out the great marine reptiles and the iconic ammonites. It was an event of almost unimaginable destruction. But in every great ending in Earth's history, there is a new beginning. The fall of the dinosaurs left a massive ecological vacuum. And cowering in the shadows, in burrows deep underground, were our own distant ancestors, small, shrew-like mammals who had managed to survive the cataclysm. With the great reptiles gone, the world was now open to them. The Chicxulub impact did not just end the age of dinosaurs, it triggered the dawn of the age of mammals, the age that would eventually lead to us. The lonely traveler that brought death from the sky also, inadvertently, cleared the path for our own existence, a profound and humbling reminder of the chaotic and unpredictable nature of life's long story. The story of the Chicxulub impact is a story of a random, unforeseen event that changed the world in a geological instant. But what if it were not unforeseen? What would happen today if our modern skywatchers detected a similar, though perhaps smaller, threat on a direct collision course with Earth? Let us imagine a scenario, not one of panic or chaos, but one of quiet, determined, and intelligent action. A new asteroid is discovered, perhaps 1 kilometer in diameter, large enough to cause global consequences. Initial orbital calculations are worrying. After several years of careful tracking by observatories around the world, the scientific community confirms, with near certainty, that it will strike the Earth in 50 years. There would be no secret to keep. The data would be public and verifiable. The first phase of humanity's response would be one of intense, collaborative science. Space agencies from every major nation would share their resources and data. The world's most powerful telescopes, both on the ground and in space, would be trained on the object, studying its every detail, its exact size and shape, its rate of rotation, its composition. Is it a solid rock or a loose rubble pile like Bennu? Knowing its physical nature would be crucial for planning a response. Supercomputers would run thousands of simulations, pinpointing the likely impact corridor and modeling the potential effects on the atmosphere and climate, giving world leaders the information they need not to incite fear, but to make rational, long-term plans. With decades of warning, humanity would not be a helpless target. We would be a problem solver. The goal would not be to destroy the asteroid, an act which could create many smaller, unpredictable fragments, but to gently nudge it off its collision course. A mission, or likely a fleet of missions, would be designed and launched by an international consortium. The primary strategy would likely be a heavy, high-speed spacecraft, a kinetic impactor, designed to collide with the asteroid. The goal is not to shatter it, but to transfer momentum, altering its velocity by just a few millimeters per second. Over the many years remaining before the predicted impact, that tiny, almost imperceptible nudge would compound, causing the asteroid's arrival time at Earth's orbit to shift by minutes, then hours, then days, until it is guaranteed to miss the Earth entirely, passing safely by in the emptiness of space. Other methods, like a gravity tractor, a spacecraft that would simply hover near the asteroid and use its own tiny gravitational pull to slowly tow it onto a new path over many years, would also be considered. This effort would be, in a sense, humanity's finest hour. A global, cosmic threat met with a unified, scientific, and peaceful response. It would be a project that unites nations, a shared goal for the protection and survival of our world. And while this scenario remains hypothetical, the first crucial step in this plan, the proof that we can indeed intentionally move an asteroid, has already been taken. The idea of humanity uniting to deflect an asteroid is not just a hopeful hypothetical, it is now a demonstrated reality. In a quiet and profound moment for our species, we proved for the first time that we are not merely passive inhabitants of the cosmic shooting gallery. We have the ability to fight back. This proof came in the form of a mission called DART, which stands for Double Asteroid Redirection Test. Its target was not a threatening asteroid, but a harmless pair of space rocks chosen for a perfect experiment, the larger asteroid Didymos, and its small moonlet, Dimorphos, which orbited it. The goal was simple in concept, but incredibly difficult in execution: to crash a spacecraft, about the size of a vending machine, directly into the 160-meter Vue de Dimorphos, and measure precisely how much its orbit around Didymos changed. On the 26th of September, 2022, after a 10-month journey across millions of kilometers of space, the DART spacecraft approached its target. In the final hour, the spacecraft was on its own, guided by a sophisticated autonomous navigation system. The images it sent back in its final moments were breathtaking. First, the Didymos system appeared as a single point of light. Then, it resolved into two, the larger Didymos and its tiny companion. In the final minutes, Dimorphos grew to fill the entire frame, its surface a field of boulders and dust. And then, at a speed of over 22,000 kilometers per hour, the signal went silent. The spacecraft had hit its mark. Telescopes on Earth and in space, including Hubble and the James Webb Space Telescope, turned their eyes to the Didymos system to watch the aftermath. They saw a brilliant plume of debris bloom from the impact site, a cloud of dust and rock blasted into space. And over the following weeks, they tracked the orbit of Dimorphos with incredible precision. The results were better than anyone had dared to hope. The impact had significantly altered Dimorphos's path, shortening its orbital period around Didymos by a full 33 minutes. The experiment was a resounding success. For the first time in the 4.5 billion year history of our world, a species had intentionally and successfully altered the motion of a celestial body. This was more than just an engineering test. It was a pivotal moment in the human story. The dinosaurs had no space program. They looked up at the sky, completely unaware of the doom that was approaching. We, however, are different. We have developed the ability to understand the cosmos, to predict its movements, and now, to influence them. The DART mission is a symbol of hope. It is the first, crucial step in developing a true planetary defense system. It is proof that knowledge, ingenuity, and collaboration can provide us with a real and powerful shield against the random dangers of the universe. The DART mission was a profound success, a message sent to the cosmos that life on Earth is no longer a passive spectator. And yet, this newfound ability to defend ourselves should not be mistaken for control. Instead, it should lead us to a deeper, more philosophical contemplation of our place in the universe. Let us consider, for a moment, the sheer, breathtaking luck of our own existence. For 4.5 billion years, our planet has been navigating this cosmic shooting gallery. It has endured the great violence of its own formation, a period known as the Late Heavy Bombardment where colossal impacts were commonplace. And since then, it has continued on its long, orbital journey, narrowly missing countless potential catastrophes. The universe does not care about life. It operates on the cold, impartial laws of physics and probability. The fact that a large civilization-ending asteroid has not struck the Earth in the last 66 million years is not a sign of destiny or protection. It is the result of a cosmic lottery, a game of chance played on an unimaginable timescale. We are the beneficiaries of an extraordinary run of good luck. The existence of our complex biosphere, the long, unbroken chain of evolution that has led from the first single-celled organism to the intricate neural network of the human brain. All of this was allowed to happen within a remarkably long period of relative peace. We live in a quiet moment, a lucky parenthesis, in the long and often violent story of the solar system. Recognizing this does not need to be a source of anxiety. It should be a source of profound gratitude and wonder. Every sunrise, every season, every breath we take is a gift, a statistical improbability made real. Our existence is not a given, it is a prize won in a cosmic lottery. And this perspective changes everything. It transforms our view of the night sky from a backdrop of passive beauty into a dynamic arena of near misses and ancient travelers. And it reframes our own role in the universe. We are not the masters of this system, but we are its lucky, conscious children, the first, as far as we know, to be able to look up, understand the odds, and feel a deep and humbling appreciation for the simple, improbable, and beautiful fact of our own survival. And so we find ourselves here, on this small blue world, looking up at a vast and dynamic sky. We have told the stories of these lonely travelers, the ancient rocks and balls of ice that wander the quiet darkness between the planets. We have seen that they are not malicious monsters, but are in fact time capsules, carrying the chemical secrets of our own origins. We have journeyed with our robotic explorers to touch them, to understand them, and to bring pieces of them home. We have followed the modern-day sky watchers, the patient sentinels who map the heavens and transform potential threats into predictable, beautiful celestial events. We have looked to our moon to read the unfiltered history of our solar system's violent past. And we have traveled back in time to witness the great impact that ended one age of life and began another. But most importantly, we have seen that for the first time in the 4.5 billion year history of this planet, one species has developed the ability to understand this cosmic context and to protect itself from it. The development of planetary defense, proven by the success of the DART mission, is a profound evolutionary leap. It is a sign that life is no longer just a passive participant in the cosmic lottery. We have become active players, capable of intelligently and peacefully nudging the universe in a safer direction. This knowledge should not bring fear. It should bring a profound sense of peace and wonder. The universe is vast and chaotic, but our understanding has become our shield. We no longer have to look at the sky with dread, but with curiosity, with respect, and with the quiet confidence that we are learning the rules of the cosmic game. And in that understanding, we can find a deep and abiding serenity. Let the silent, patient orbits of these ancient travelers be a reminder of the immense timescales of the cosmos. And let the quiet, dedicated work of our scientists be a comfort, a sign of humanity's shared drive to explore, to understand, and to protect our fragile home. There is peace to be found beneath the starry sky, the peace of knowing our place within it all. Sleep well.